Okay guys, here we go. Now I have been making videos for 2 days now for my other classes because I have 4 preps, and I can tell you that this is not nearly as much fun without you guys. This is the first thing that we're going to start with. You need to find the page that says warm up after 11:7, and you need to print that off or write it down, have it to reference, and I want you to see what you can do working through it. This is what we did before spring break. So I want you to see what you can do with it. And then here in just a minute, we're going to walk through it, but it's important that you try your hand at it first. Okay, hopefully you paused me and you're ready to run through these and do a little bit of practice with fundamental counting principle and permutations. Number 1, which applies? Only one set of items or people, that's when we use a permutation. If we have more than one set, only one set is permutation, more than one set is my fundamental counting principle. I'm going to use factorials as part of the solution when I'm doing permutation. It may end up looking like factorials when I'm doing fundamental counting principle, but that is not an always option. Number 4, options can be shown with a tree diagram or organized list for my fundamental counting principle. We only want to do that when we have a small number of selections. Otherwise, it can get crazy. And it's found by multiplying the number of ways each event can occur. That is my fundamental counting principle. Okay, evaluating expressions using factorials and permutations. We're going to concentrate on using your calculator for these. Remember that 0 factorial is defined as 1. 6 factorial, to work that out, it would be 6 times 5 times 4 times 3 times 2 times 1. Let's go ahead though and look at our calculator. Excuse me with all that. If I want to do 6 factorial, I'm going to type in the 6, go to probability, over to factorial, enter. There's my 6 factorial. That gives me 720. Now I skipped number 7. 1 factorial is also 1. 0 factorial is defined as 1. 1 factorial is defined as 1. Keep that in mind as we move forward. 5 pick 2 is 5 permutations of 5 items. I'm going to pick 2 of them and I'm doing permutations. This looks like 5 times 4 or 20 if I want to work it out. 12 pick 3 would be 12 times 11 times 10 because I'm starting with 12 and I've got 3 blanks to fill, 3 selections to make. That comes out as 1,320. 6 pick 0. There's only one way to pick nothing. You can do that in your calculator or you can reason through it. Okay, 12 through 15 says to show how to simplify and then evaluate. So we're first going to simplify and then we're going to work out an answer. Remember how we reduced to see what we can cancel out? Well, we've got 52 factorial in the numerator and 50 factorial in the denominator. I'm going to stop at that 50 factorial. It is going to cancel, but I've got to start at 52. So I say 52 times 51 times 50 factorial. The 50 factorials cancel out, and I'm left with 52 times 51, which I pull out my calculator and discovers 2,652. For the next problem, in my denominator, I have 2 factorial, 3 factorial. Well, 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Make sure you include all of that. My numerator is 5 factorial. I can do 5 times 4 times 3 times 2 times 1, or I can just do 3 factorial. I could have left that 3 factorial in my denominator to cancel it as a factorial. That would have been fine. I see that I've got 20 divided by 2, which is 10. Now you may cancel a little bit differently in a different order. That's fine. You need to show me how you can simplify, and you need to get that result of 10. All right, 20 factorial in my numerator, 5 factorial, and 15 factorial in my denominator. Well, I'm going to focus on that 15 factorial. I know that that is going to cancel out. So if I do 20, 19, 18, 17, 16, I can stop at 15 factorial because that is going to cancel out. I also have this 5 factorial in my denominator. So I need to consider that. 5 times 4 times 3 times 2 times 1. 15 factorial over 15 factorial cancels. And now let's look to see what else we can simplify by. This is another instance where you can do this differently. We're going to do it this way because I have you as a captive audience. 5 times 4 is 20. So 20 over 20 cancels. I have a 3 times 2 in my denominator. That's 6. 3 times 2 is 6. 18 divided by 6 is 3. However you do your cancellation, make sure that your result when you simplify is 15,504. One more practice problem, simplifying these factorial expressions. I've got a 14 factorial in my denominator, so that's where I'm going to stop in my numerator. Oops, 16, 15, 14 factorial. I also have a 3 factorial in my denominator, 3 times 2 times 1. That 14 factorial cancels out. Now, if this last one confused you the way we did it, let's look at this one. We've got 17, 16, 15 multiplied together in my numerator. If I do that multiplication, 17 times 16 times 15, my numerator is 4,080. My denominator is 6. 3 times 2 times 1 is 6. So I can do 4,080 divided by 6, and I get 680 as my result. That's absolutely acceptable. The last two problems on this front side are doing permutations with duplicates. When I do permutations with duplicates, I need to divide out the duplicate items. I need to figure out how many different ways I can arrange these letters. Well, first I need to know how many letters I have. So I count the number of letters in management, and I find I have 10. So that means my numerator is 10 factorial. For my denominator, I need to see what letters are duplicated and how many times they show up. I have 2 m's, so that's a 2 factorial for the m. I have 2 a's, so that's a 2 factorial for the a's. I have 2 n's, so that's a 2 factorial for the n's. And then I also have 2 e's, so another 2 factorial for the e's. Now, 2 factorial is just 2 times 1. So that means that my denominator really is just 2 times 2 times 2 times 2. Well, 2 times itself 4 times is 16. So I have 10 factorial divided by 16. You can work that out with your calculator, and that's what you should get. One more permutation with duplicates problem. If you had to follow along with me on number 16, pause the video. Do number 17 by yourself, and then see if we get the same result. All right, let's look at the back page. Let's look at the back page. On the back, decide if the situation is an example of permutation or a fundamental counting principle, and then we're going to solve. I have 3 of those situations that I'm going to decide what they are and then solve to figure out how many. Number 18, how many ways can a baseball team manager arrange his batting order of 9 players? Well, it's either a fundamental counting principle, and we can slow that, or I didn't mean to mark that out and to underline it. FCP, fundamental counting principle, or I'm going to say permutation, PERM. I'm trying to arrange one set of players. If it's just one set, it's a permutation. If it's just one set, it's a permutation. They're all going to bat. So first person up, I've got 9 people to pick for. Once that first batter's been selected, there's only 8 people to pick. Then 7, then 6. This ends up being 9 factorial to find out how many different batting orders there are. And you know how to do that on your calculator. I would keep going until I got to 1. All right, number 19. The Johnsons just got a new house and they're picking out furniture. Now, they don't need a lot, but they still need a sofa, a chair, and a table for their living room. There are 5 different sofas they all like, 3 comfortable chairs to choose from, and 4 different tables that are big enough. How many different possible looks are there for the new living room furniture? Well, how many sets do I have? Do I have just 1 set or do I have more than 1 set? I actually have 3 sets of items. I have a set of sofas, a set of chairs, and a set of tables. Since I have more than 1 set, I have 3 sets in this problem, I'm going to be using the fundamental counting principle. I need to pick 3 things. I need to pick a sofa, I need to pick a chair, and I need to pick a table. Sofa, chair, table. Well, there are 5 different sofas that we liked, 3 different chairs that'll work, and 4 different tables that'll work. That means that there are 5 times 3 times 4, or 60 different looks for the living room, depending on which combination of those I get. All right, number 20. At the reception line of a wedding, I have bride, groom, best man, maid of honor, 3 groomsmen, and 3 bridesmaids who all have to line up and shake hands and hug necks. How many ways can they arrange themselves if it doesn't matter who goes where? Okay, well, first of all, how many sets do we have? We are lining up 1 set of people. These are all the people that are in the wedding party, but it's just 1 set of people. And if it's just 1 set, it's a permutation. So now we need to see, okay, how many different ways can they line up? Well, we've got, let's count, a bride, a groom, a best man, a maid of honor. 1, 2, 3, 4. Then we've got 3 groomsmen, so 4 plus 3 is 7, plus 3 more bridesmaids means 10 people. So just like my baseball batting order, I'm getting the reception line. And there's 10 different spots that need to be filled. 10 different spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I made too many spots. The first person, there's 10 different people that can stand first, and then 9 different people that can stand second, and then 8 different people that can stand third, etc., etc. All right, guys, I had a quick distraction, but we are back. So we are lining up our reception line at the wedding. We're starting with 10 different people who could be in the first spot, and then 9, and then I work my way down to 1. So that works out to be a 10 factorial, which is 3,628,800 different ways to line up 10 people. But what if the groom has to be last and the bride has to be next to the groom? Well, if the groom has to be last and the bride has to be next to the groom, how many people are we actually lining up? We're only lining up 8 people in that case. So I would do 8 factorial, which brings my number of possibilities down to 40,320. Okay, simplifying fractions. This is a review to get you moving toward what we were going to be doing next. You are going to write each fraction in lowest terms by dividing out the common factors. 4 and 8 are both divisible by 4, so that will reduce to 1/2. 9 and 12 are both divisible by 3, so that reduces to 3/4. 15 and 20 are both divisible by 5, so that also reduces to 3/4. 7 and 14 are both divisible by 7, that reduces to 1/2. 3 and 9 are both divisible by 3. 12 and 18 are both divisible by 6. So that is how we get fractions to lowest terms. And then I've got a quick set theory review. I've got set A, set B, and then of course my universal set out here. And I asked you, what is in A union B? Remember that my union symbol means or. So if it's an A or B or both, I get to count it. The numbers 2, 3, and 4 are in that union. When I flip that symbol upside down, now it means intersection, and I'm interested in the and. The only element that is in both A and B is 3. All right, that is our warm-up. That gets us moving. You need to print off your guided notes and be ready to do 11-8.